computer. All right. So this is the beginning of our internet unit. So welcome to the internet. What is the internet? Now, I think I pointed out this little comic last time we were in person. I posted it on the wall, but this is a little a chart of all the terms that this webcomic artist has heard used or used himself to make fun of the internet. My favorite one on this list is the Blagoblag. It's a very fun name for the internet. But as I'm sure we're all well aware at this point, the internet is hugely important to our lives as we know them, especially right now as we're all learning from home again. We couldn't have these lessons without the internet. So in this unit, we're going to be learning about how the internet works. Now we're answering questions like, what is the internet? How does it work? What impact has the internet had on society? So all kinds of questions we will be answering about the internet. So at its core, the internet is a philosophy of making information and knowledge open and accessible to everyone. We want everyone to have access to all of the information they could possibly want or need. And as our world becomes increasingly interconnected, we are more and more able to share all of the knowledge that we are accumulating with anyone who has a connection to the internet. So physically, how it works, the internet is a network of networks, which allows devices from all over the world to connect to each other. And as we go further in this unit, we will have more in-depth description of how it all actually works. And all of this happens because it's built on open, agreed upon protocols. Again, we'll talk about that later in the unit. So a protocol, just general definition, a protocol is a widely agreed upon set of rules that standardize communication between machines. We want a specific set of rules so that different computers know how to talk to each other. If we don't have a protocol defined, different devices would not be able to communicate with each other very easily because each computer might be speaking a different language. Last unit, during the data unit, or the digital information, we learned about things like ASCII. ASCII is the standard information interchange, like that's how we encode characters in binary, in numbers, so that every computer understands when I get a message that's in ASCII, that's encoded like this, every computer knows how to decode it into something that we can read. So making sure that every computer understands how to communicate with every other computer allows us to have them efficiently communicate with each other. So the internet is a way for all machines, not just computers, I guess technically all computers, but not just what we think of as computers, our phones, and increasingly other devices, watches, fridges, microwaves, I don't know, all kinds of devices to communicate with one another, and for us as humans to communicate with one another through those devices. As long as two human beings have access to the internet, they are able to communicate across any distance. Now, the internet is huge. In the year 2005, so a long time ago, about 16% of the world was online, with 51% of the developed world and 8% of the developing world being connected to the internet. If we fast forward almost a decade to 2014, we've increased from 16 to 40% of the entire world being online, 50 to 78% of the developed world, and 8 to 32% of the developing world. So the developing world is becoming increasingly connected. And even just last year, almost 59% of the global population was online, which is a mind-boggling number of people. That's 4.5 billion people connected to the internet. Lots and lots of people, lots and lots of devices. So as we can see through time, we are rapidly increasing the number of people, the quantity of people, the ratio of people who are connected versus those who are not. Now, according to current statistics, I changed these, I think, last week. There are almost 10,000 tweets sent, almost 100,000 Google searches, over 3 million emails sent, about 2/3 of which are spam, and 138,000 gigabytes of internet traffic. What time frame do we think this falls into? One second is correct. Every 1 second, these things take place, which is wild. That's so many tweets, Google searches, emails. So much of the internet is being used all the time. So there's a very cool website, internetlivestats.com, where you can look at these statistics live. It's live stats. So it'll show you even in a visual way how many tweets, Google searches are being performed. It's a very cool website. Just a little bit of discussion on the impact of the internet. Obviously, the internet has a huge impact on our lives and how we live them. They enable a lot of collaboration where people, wherever they are able to work together. I'm on campus, you are each in your own individual homes, and we can still all communicate and collaborate on class here. We can communicate with each other. We can get information across. Right now, I'm getting information across to y'all. We can crowdsource. If there's a Kickstarter or a GoFundMe that needs to be funded, that's one of the great things about the internet. As well as anonymity and censorship. Not everything about the internet is hunky-dory. And we'll get into discussion a little bit about each of these. But email, video calls, social media, digital learning, all of these are possible through the internet. We have opened up huge different avenues for collaboration using the internet. There's different social media campaigns that have done all kinds of crowdsourcing across lots of people. There's scientific programs like Fold It and Folding at Home are two examples that I have found where they crowdsource research on protein folding. We're going to talk about Web3 this year. I don't think so, but I will look into it and see if we maybe do talk about it. I don't think it's part of the curriculum on CodeHS, but if it seems important, I will do my best to fold it in. So yes, I will take a note of that. Yeah, all kinds of collaboration is enabled by the internet. Obviously, we do a lot of buying things online. Amazon has grown and grown and is now one of the biggest companies ever. So online shopping lets us as consumers purchase our goods directly from the retailers without needing to leave our homes. It also lets people who don't have the funds to run a physical store or want to sell to people who aren't near them, sell their stuff. Like with Etsy, people can create super niche things, and people who want that niche thing from all over the place are able to purchase that very niche thing. And we're also able to get the best possible deal on any product we're trying to purchase. We're not disadvantaged by where we live or lack of knowledge. We can do some research on the internet and, hey, find the best possible deal for any given thing. And crowdfunding also, like I mentioned before, huge sector of e-commerce. Kickstarter, Indiegogo, GoFundMe, they let people, wherever they are, contribute money to ideas or causes that they find worthy of their cash. Now, because of the internet, there is this huge amount of freedom of information, and this is both good and potentially bad. There's so much information available for anyone and everyone to access. if you want to learn about something, whether it's programming, math, science, absolutely whatever, you are able to learn that on the internet via all kinds of different websites, Skillshare, YouTube, scientific publications. You don't have to be going to a research institution. You don't have to be attending a high-level school to have access to high-level scientific research. However, other more negative sides of this freedom of information also exist. Things like WikiLeaks. There are possible dangers of classified secrets becoming public, which is not really what we want. We want classified things generally to stay classified, where sometimes it is good for classified things to become declassified, but not always. You know, obviously we are doing online learning right now. Again, here we are. But learning all over the world is becoming more and more blended in general. Even when we're in person, we're still doing a lot of our work through CodeHS, which is entirely hosted online. So we wouldn't be able to have that same process. We wouldn't be able to have all of our CodeHS stuff if the internet didn't exist. The internet opens up a large amount of entertainment. YouTube, Netflix, Hulu, gaming, all kinds of things are made available. Memes as well, of course. We all love memes. Now, there are both benefits, as I've talked about, lots of benefits, and there are also downsides to the freedom of information from the internet. So one thing is access to copyrighted material, pirating. We don't really feel the negative impact of this, but corporations or media companies can feel negatively impacted by copyright infringement. Anonymity and censorship are also potential problems. As we discuss anonymity, there's different facets to this even within itself. Once everyone on the internet is anonymous, there's no bias. There's no targeting or discrimination based on who you are if you are anonymous. However, that anonymity also gives rise to things like cyberbullying. If your actions are anonymous, there's no one to hold you accountable for your actions if you are rude or unkind or just horrible to someone else online. So there's two sides to this anonymity, both good and bad. And just the idea of online censorship. Should Google display search results that have explicit or illegal content? Should governments be allowed to filter what kind of content its citizens see? Now, there's all kinds of different questions like this being posed by corporations, governments in these discussions about the internet. So lots and lots of things to talk about in and around the internet. And we'll be doing deeper dives into basically all of this later. So many areas of our lives are impacted by the internet, sometimes in ways we don't even recognize. Throughout this unit, we were learning about how the internet, along with diving a little bit deeper into the impacts it has on society as we know it. So that is our very brief welcome to the internet. Now, our second topic for the day, we are going to talk about internet hardware. This is going to be our first introduction into the how, and we will be getting further into the nitty-gritty as we move forward. So the internet is a network of networks. Now, what is a network? A network is a group of two or more computer systems linked together. So if I have two computers and they're connected via some cable, I can have a smiley face transmitted across that cable, and hey, the other computer has received that smiley face. Now, as we have more and more devices, we're going to have connections between each and every device if we want them to be able to communicate. Now, this solution obviously is not very scalable. When we only had 2 devices, we had 1 connection. Now, when we have 4 devices, we have 1, 2, 3, 4, 5, 6 connections. As we add more and more devices, it's going to be untenable to have every device have an individual connection to every single other device. That's just not possible because there are billions of devices connected to the internet. Just remembering the connection for every single device doesn't work. We would not be able to do that. There's not enough space to remember that. So the solution to this problem, at least at a very small scale, is to connect each device to a central hub, sending information through that hub to other devices. So I can, this hub, we call these routers. So if this computer wants to send a signal to that computer, we send a connection to the router. The router routes that message to the other computer, which receives the smiley face. Now, one router is capable of connecting a pretty good number of devices, provided that they are close enough together. Generally, a small network like this will be able to encompass all of the devices in a single room or potentially a single building. If your home has Wi-Fi, you almost certainly have a router in your home, a Wi-Fi router that is providing Wi-Fi access to all of the devices in your house. Now, different routers are going to be used for different locations. So what if I want to send a message from school to your home, like is happening right now? Yes, Brandon.
So what would be the difference between a router and a modem?
A modem and so that's like a physical internet hardware, like a physical in your home hardware kind of thing. I'm not 100% sure the answer at the moment. But yeah, the modem is, I think, how you get from a coaxial connection to having Ethernet connections. I'm not 100% sure on that though.
Okay, thank you.
I will do some research and get back to you.
Okay.
Thank you. Yeah, so let's say I'm on the school's internet and you are each on your own home's internet. How are we talking to each other? I'm not on the same router as you guys. We are on different routers. So what we do essentially is we connect to a router in the middle. All 3 of these could be connected to one router in the center. So we're getting a message from my computer at school through that router to your router at home to your computer. Now, as we add more and more networks, we can't just have one router in the middle anymore. Again, we get too much traffic. So the internet is a huge network of different routers, which are all interconnected in various ways. Not every router is connected to every other router. Each one is connected to a few others, but you can find a path from one to any other point eventually. All right, Eric says, router connects devices to Wi-Fi, modem connects Wi-Fi to the internet. That seems very correct. Yes, thank you for that. So here's our very small depiction of the internet. Individual networks, individual routers are connecting to a router that is connected to the internet. This connection is usually facilitated by an internet service provider or ISP. So right now, we don't really need to focus on how this huge interconnected cloud of routers works. We're going to abstract it away and just call it the internet. We connect our router to the internet and we send messages through the internet and they connect to other routers. We'll be diving into this cloud later in this unit, but for right now, we're going to kind of obfuscate. So sending information is the core functionality of the internet. That's what it's really designed for. So if we can kind of imagine this little tree chart as the internet, there's one point of failure here, not quite true of the whole internet. But we can say if I'm sending a connection from this point to this point, those are my computer references on the internet on this diagram, I can find a path to get that information over there. Now, obviously, we're not sending physical information. We are sending binary code that translates to a colon and a right parenthesis in ASCII. So at a very basic level, all we need to do is get digital information from one computer to another computer. So there are three primary methods that are used to transmit digital information. There's electricity, light, and radio. So electricity is pretty much the most common method. We usually use Ethernet cables. All of the computers in the classroom are connected to an Ethernet cable. It's likely that at least one or two devices in your home is connected to the internet via Ethernet. Some pros of Ethernet: it is very cheap, but it only covers medium distances. When we are sending connections via Ethernet, we're essentially going to send high voltage to send a 1 in binary, or a 0 would be low or no voltage. If we want to send information via light, we're going to use what we call a fiber optic cable, which are very, very long distance. These are really good cables to send super long distance information. However, they are very expensive. They're much more expensive than Ethernet because the materials required to build them are just more expensive. And the principle on how they work, very, very similar. When we send a bright light, this should say via light, that's my bad. When we send a light, we are sending a 1. When we are sending a dim light or turning off the light, we're sending a 0. And our third way is with radio waves. This is how Wi-Fi works. So we are sending digital information through radio waves. You cannot see the welcome to the internet slides on linguavcs.net. Okay, thank you for letting me know. I will get those. I'll check that out in a minute when I finish this presentation. Pros, obviously wireless. I know that my computer right now is connected to the internet wirelessly. I'm connected to the school's Wi-Fi. Most of you are also probably connected to your home Wi-Fi, to your Wi-Fi router. So this is great because we do not need a physical connection. However, Wi-Fi and all wireless internet tends to be much shorter range than either of the previous two physical connections were. So if we want to send digital information through radio waves, we don't need any cables at all. We just need a Wi-Fi router or a cell tower. We would send a high frequency wave to give a 1, low frequency wave to give a 0. So no matter what kind of information we are sending, we are able to send bits from one computer to another computer. So if I'm sending 1010, I would turn my signal on, off, and there we go. We have sent 1010. Our communication was successful. Now, what if my signal is something like 10001? I can send 10001. Now, my thing that I sent is not the same as the thing I received because I just saw a whole bunch of off. So I just kind of interpreted that as just 10. That's not what we want. So in order to solve that, we are going to use a clock. which allows computers to agree on how often to send or receive bits. So here, I'm going to send a 1, wait for a tick, receive a 0, wait for a tick, receive a 0, wait for a tick, receive a 0, wait for a tick, receive a 1. And hey, now our messages line up because they are sending and receiving at the same rate. Now, in this example, we transferred 1 bit roughly every second. And this is so slow. It would take almost an eternity to get any actual information if we were sending 1 bit per second. Fortunately, computers work much, much faster than that. And the amount of data that is able to be transferred by a single system is called that system's bandwidth. It is measured by its bit rate, lots of vocabulary being thrown out here, which is the number of bits that can be sent or received by a signal or by a system in a single second. So if we have a low bandwidth, we might have a bit rate of 1 bit per second. This is excruciatingly slow. Like I just said, 1 bit per second, you would not be able to get anything at all in that rate. A high bandwidth might be 5 megabits per second. So 5,000 bits per second, as opposed to just 1 bit per second, is a much better bandwidth, much higher bit rate. Now, one last thing to take into account while we're talking about internet communications is the idea of latency, how much time it takes for a bit to be sent from the sender to the receiver. If you have low latency, you have a fast connection. If you have high latency, you have a slow connection. If you ever played games online, you might have the idea of ping. It's how much time it takes for your signal to reach the server. So if you have a high ping, it takes a long time for your actions to be sent to the server, other people's actions to be sent to you. That is how we experience lag. People with a high amount of time in between their actions being sent to the server and vice versa. So fiber optic cable has the best latency because it's a very high quality. Using light, you can transmit at the speed of light through glass, which is about 5 microseconds per kilometer, which is very, very good. Ethernet cables have a much higher latency of around 300 microseconds per kilometer, although Ethernet connections generally shorter than a kilometer long. Kilometer is a very long connection to make. Generally, you're going to have tens or maybe even very sometimes you'll have hundreds of feet. So, brief recap of discussion for today. The internet is a network that connects other networks, where a network is a group of 2 or more connected computers, which are traditionally connected via routers. There are all kinds of different ways to send digital information: electricity through Ethernet, light through fiber optic, or radio waves through Wi-Fi. And no matter what kind of connection we are using, all we're essentially doing is sending bits, binary data, 1s and 0s, which are interpreted on the other end to get the message. Any queries on our topics for today?
Yes, Mr.
Yes. That was some echo. I'm guessing you're probably typing it in chat because of the echo. Yes. Where do we usually use fiber optic in real life? I know that a lot of cities are starting to implement fiber optic connections. I think San Jose recently started putting in fiber optic. I think AT&T is now using fiber optic cables to transmit internet. They're also definitely used, I believe, in like cross-continental communications, because so like that's what's under the sea, I believe, is fiber optic because that is a very, very long distance, and being able to communicate quickly across those distances is pretty important. So there's various places that fiber optic is used, but it's generally more used in commercial use than home use. So around your house, you would have Wi-Fi or Ethernet connections where like your internet service provider might be using fiber optic for like their connections to the internet, or helping you connect to the internet. That make sense? Cool. All right, any other questions? Cool. I will stop my recording.